Unruh radiation. This is today's topic. Here, Unruh radiation, you know Hawking radiation. Similarly, there is Unruh radiation. If you study general theory of relativity, okay, and quantum field theory, in both the cases you will find this topic, Unruh radiation. And this falls under the subject heading of theoretical physics. Yes, Unruh radiation is a theoretical prediction. Okay, there is still no experimental verification of this radiation. This stems from the concepts of two subjects. One is quantum field theory and another one is relativistic mechanics or general theory of relativity of Einstein. So what is this Unruh radiation? If a person accelerates through empty space, if a person or anyone, okay, or any object accelerates through empty space, then that object or that man experiences a bath of radiation or bath of virtual particle-antiparticle pairs. Okay, means there is a shower of particle-antiparticle pairs on that object or on that man, and that is known as Unruh radiation. Though for an outside observer means the person who is not accelerating at all, he is resting at an inertial frame of reference. For that person, nothing special happens. Nothing special happens. Friends, that means he won't observe that radiation. Okay? Empty space will remain empty, or the vacuum will remain empty for the outside observer. So this is the concept of Unruh radiation. Just keep in your mind that this is a theoretical prediction. There is no still experimental verification of this radiation. So origin, I have already talked about origin, and who is the originator means the person, the physicist who proposed this concept. Name of that person is name of that physicist is William G. Unruh. William G. Unruh in 1976. Okay, in 1976 he proposed this concept. Then comes the point acceleration and horizon. So I have already talked about acceleration. If you were accelerating through empty space, then only this thing will happen. Means you will observe Unruh radiation. And what is Unruh radiation? It is a bath of virtual particle-antiparticle pairs on you. That is Unruh radiation. Okay? And one term has been used there, horizon. Yes, you have event horizon. That concept is used for the study of black holes. Nothing can escape the boundary or the event horizon. Event horizon is nothing but a boundary. Okay, nothing can escape that boundary. Whatever inside that boundary is there, that cannot escape. Even light cannot escape the event horizon. In case of Unruh radiation also, there is a concept like event horizon, and that is known as only horizon. That is also a boundary beyond which nothing can be observed. No information is obtained from inside the boundary. That means when there is an outside observer, that means who is not accelerating. And here the person in question is accelerating through vacuum. Okay. So for the outside observer, nothing special happens. No information he will receive from that accelerating person, because there is a presence of horizon. Okay? That is acting as a boundary. Right? Same as concept is similar to event horizon in case of black holes. Next point is quantum vacuum. Yes, we are talking about empty space, vacuum. Quantum vacuum means means empty space is actually not empty. That is the concept of quantum vacuum. Empty space is not actually empty. That means empty space is filled with fluctuations, which is called quantum fluctuations. Fluctuations of what? Fluctuations of virtual particle-antiparticle pairs. They are continually popping in and popping out of existence. Means continually there is creation and annihilation of particle-antiparticle pairs. You know that when a particle comes in contact with antiparticle, there is an explosion, there is an annihilation of those pairs. That is known to you. So here also same thing happens. So vacuum is actually not vacuum, or empty space is actually not empty. There is fluctuation of pairs of particle-antiparticles. Okay. So that was quantum vacuum. Next is, okay, one more point. In addition to this, I want to say that for the outside observer, he will not observe that fluctuation. Okay, that quantum fluctuation he won't observe at all. Actually, that quantum fluctuation, that is acting as the shower of particle-antiparticle pairs on that person. Okay, that fluctuation. And that fluctuation won't be observed by any outside observer. Okay, and next is Hawking radiation. It's Hawking. Hawking radiation analogy. That is one more point in this context. Okay, Hawking radiation analogy. Yes, it is analogous. Unruh radiation is analogous to Hawking radiation. You know that Hawking radiation, this is considered in case of black holes. Near the event horizons, due to quantum mechanics, the effects of quantum mechanics, okay, there is also a formation of pairs of particles and antiparticles. And out of the pairs means two particles are there. So one particle remains inside the black hole and one particle can escape through the boundary of the event horizon. And that way black holes lose their mass that way. Because out of two particles, means out of a pair, one particle escapes the boundary of the event horizon. That is the concept of Hawking radiation. Okay, here also in case of Unruh radiation, same thing happens. So this is the analogy between Hawking radiation and Unruh radiation. Okay, and the next point is perception. Yes, I have already talked about perception. The birth of particle-antiparticle pairs that will be perceived only for the accelerating object or the accelerating man or person, okay, or the accelerating observer. That Unruh radiation will be perceived only by accelerating observer, not for that observer who is not accelerating at all, who stays in inertial frame of reference. That person won't observe that Unruh radiation. Okay, so this is the point, perception. who will perceive and who will not. Okay? And last point is temperature. Yes, temperature, there is bath of particle-antiparticle pairs. So since there is bath of particle-antiparticle pairs, those pairs are bombarding upon you when you are accelerating. That means it is related with the rate of acceleration. So according to the prediction of the physicists about Unruh radiation, according to them, it is the temperature is proportional to the rate of acceleration. Okay, if rate of acceleration is more, then the temperature perceived by that observer, means perceived by that accelerating observer, will be more. They are proportional to each other. Once at the end of this lecture, I want to mention again one thing, the same thing, not one thing, the same thing, that is Unruh radiation is still a concept. It is a theoretical concept. Still there is no practical evidence of this. Still this is very interesting. So researches are going on. Okay. And this stems from two subjects. Those are quantum field theory and relativistic mechanics, or Einstein's general theory of relativity. If you study all these two subjects in detail, then you will get this topic, Unruh radiation. Okay, so this was all about Unruh radiation. This is the end of this video. Thank you for watching this video.